Namaskar, welcome back. So this was the last part which where we stopped our discussion talking about the delta area, and as I told that this part we will also discuss in detail when we are talking on Kutch part and what were the reasons for changing the landscape in last 4,000 years and uh, why the settlements were been forced to transfer from that place. Okay. Now coming to the portion where we were discussing about the geomorphic markers. So before that, we'll just look at a few very basic things about the drainage system and channel pattern and all that. So in total, mostly what we come across is that we have three type of channel patterns: straight, meandering, and braided, and we can have the combination of either of this also. Okay, so straight channels are rare. Mostly we see that because of the velocity and sediment bed load, we will come across different type of channel patterns, but straight channel can be a part of the braided or meander also. Okay, and in case of the straight channels, the highest velocity we will encounter along the central part of the channel where it is given as a pool. So this will be the maximum energy, or we can say the velocity in this portion of the straight channel. Whereas in meander, we will have on the either side or on the outer portion, we'll have that is the erosional part that will have your uh, maximum velocity plus it will have depth also, higher depth as compared to the other bank, opposite bank, and this will have an erosional capability of that. So it will be in sort of an eroding bank, we can say. So if a stream channel has many curves, the channel pattern is we term this as a sinus channel. So so this part will be an erosive side, whereas this area will be your depositional portion. Okay. So you will see a deposition taking place on the other side of the bank, okay, which has a lower velocity. So in many streams, the channel forms a series of meanders. Okay, so you will come across a sort of an winding up channels like this. Okay, so one of its bank, for example, if this is flowing in this direction, so this will be an erosive bank, and this will be your depositional bank. So these are few like enlarged photograph which you can go through when you get the slides. Now stream valley channels and floodplains, if we look at, then mostly on the depositional side we see a sort of in floodplains which are having like low velocity and the sediments are been dumped on that side. Okay, so meander shifts are very common in the alluvial plain areas, and such shifts should not be mistaken with the tectonics. Okay, so that is the one of the main reason why we are also trying to learn about the meandering streams. Okay, if you see this in cross section, okay, then as we were discussing that the outer bank will be an erosional bank or erosive bank, and that will have deeper uh, path. Okay, so the river bed will be deeper at this area, and this will be sort of an what we call as an migratory bank, which we will have deposition, and it will keep on migrating on this in this direction. Okay, whereas this will keep eroding further. So section, you can see this is what we usually call this as a sigmoidal cross stratification uh, in the point bar region. So this is another like information which we can keep in mind, that wherever we are having the depositional side, okay, so that will have mostly the finer deposits, whereas the flow depths which are higher, and also or we can say the velocity is also higher, then we will see in that region mostly the coarser deposits. Okay. So cross section has been shown here, and then the velocity has been shown by the by different color of blue shade here. So that you can see that in the straight channels, this is the highest velocity, higher velocity, and then in case of and then you have on the either side you have medium velocities, whereas in the case of meander, you will have the higher velocity on this side, and then you have the lower velocity on this side. Okay, here. So that is what is meant, and plus what we should keep in mind that the sediment bed load will also vary from on either bank. That is, we will have finer deposits here. Okay, these are all finer deposits, medium to fine and very fine deposits you will see on this side, and the coarser ones you will see on the other side, that is erosive bank, because the velocity is also higher there and channel depth is also comparatively higher. So meander dynamics, as we have seen in the previous slide, we have maximum depth on the erosional side, and that is known as the point of like what we call the area of maximum slope as well as greater energy, and termed as thalwich. And in alluvial plains, mostly what we see is the cutoff channels. Okay, and the formation of cutoff channel is also a very simple process, and it is natural process. It is nothing to do with the tectonics. Okay, but some people try to interpret this as that there is a fault here which was responsible for the cutoff channel here, but the cutoff channel has nothing to do with the tectonics. Okay, so for example, if you see this channel here, it shows this is the cutoff bank. So this cutoff bank is also known as like cutoff channel, we can say, is also known as oxbow lake. Because of its shape, it has been termed as oxbow lake here. Okay. So if we try to reconstruct that what was the flow, previous flow, then the channel used to flow like this. Okay, and this is now because of the erosion, this portion has like is get connected, and then you have the straight channel. So in future, this part also, so right now it is having this bank here, so it will keep on migrating this side. Okay, and this will also migrate this side, and then you have a straight channel which is flowing. So this will be left out cutoff bank. So such features should be kept in mind when we are interpreting or trying to understand about the tectonic influence on the landscape development. Okay. So as I told that there was one research which was been published, and then people talk about that the meander, the big huge meander which exists here, okay, close to the Kanpur, that is on the eastern bank of Ganga river. This is your Ganga channel here. So this cutoff was been marked as in that this was because of the lineament here, and that has resulted into the cutoff bank. But this is one like this process is one of the most common process seen in alluvial plains. Okay, so you will come across many such meanders. So this is close to a close-up view of that, and this meander is something like this. Okay, so this is a cutoff bank of Ganga channel, and even you can make out few more on this side in the floodplain area. So these are all cutoff channels which was occupied earlier by the active Ganga channel. So this is a close up of that, you can see. So river has, so this used to flow like that, okay, earlier, and then now I've started flowing straight because of its process where we have these two banks are having erosive nature. So this exactly is the process what will happen. Okay, so initially the river is in this state, and then both the banks are erosive. They will come closer to each other and allow the channel to flow or get connected with the own channel and start flowing very straight. Okay. And on other side, that is your depositional side, what we will call this as a landform as in point bar. So this is one example of like what we say the creation of the ox pull lake. What is the process? So this diagram explains the complete process of the meander. The slowly the meander becomes like a neck to neck, and it becomes narrower, and then finally it get cut off from the bank, and that the shape we based on that we call this as an ox pull lakes also. Okay. So this is an example just to give an idea that what usually happens if you are having your houses sitting on the meandering side. Okay. So this is from Washington, Newakum River. So this is the final stage of that. Of course, by now it might have fallen down because of the bank erosion. Then there is another example which we usually take and try to understand the landforms is from a few kilometers down, close to Hamirpur, and that is the where the Ganga and not Ganga exactly, but the Yamuna and its tributary meets, and it is somewhere over here in this area, and where we see a sort of an Hamirpur that there is an erosive bank over on this side, okay, and then you have a straight channel of Yamuna flowing this side. So over the time, this will definitely go and meet and this main channel, and this portion will be sort of an left out part of the stream. So this is going to happen in future. So I'm not very sure that what is the fate of this Hamirpur town in this area. Now coming to the braided channels, as we have discussed that it will have multiple channels which are rejoining each other, and the portion in the center will be your islands. Okay, that is what we call braid bars, and these channels are typical of like uh, it divides into a series of braided braids separated by islands, and usually it carries coarser bed load. Okay, so there are few points where which talks about that how this braided rivers or the streams are been formed or the braided channels are formed, and where you have energy stream energy is high one. Okay, the channel gradient is steep. Third, the sediment supply is high with coarser bed load supplied from hill slope, tributaries, or we can have like glacial melts also. And fourth is the bank material is erodible, allowing the channel to shift sideways easily. Okay. So basically, such channels will not be having very like greater depth, but it will carry very coarser bed loads, and the gradient will be steeper. So this all things, and the energy conditions will be higher in this area. So this is one. Another one. This is so this is for the braided, and there is another pattern, channel pattern, which we call anastomosing channels. Okay. So they almost mimic, okay, the braided channels. So anastomosing channels have set of tributaries that branch and rejoins. Okay. They mimic braided channels, but braided channels are single channel form where the flow is diverted around the obstacle that is here within the channel, that is your braid bars. Okay. Whereas the anastomotic channels are a set of interconnected channels. Okay. So you will have multiple small channels which are interconnected. Okay. Separated by bedrock or stable alluvium, that is again bars. Okay. Under low energy conditions. So this is that there we are seeing high energy conditions, but here it will have low energy condition. And anastomotic channels are formed by a gradation process. Okay. So that's a depositional process which involves high suspended load. So high suspended load, it obviously talks about the finer material whereas in braided we have coarser material. So suspended load at sites where lateral expand is restricted, whereas in the braided river it will expands laterally. So this is what typical bars will be seen if you look at the braided channels or so. Okay. And then the most important part for us actually. Okay. Of course, the channel pattern is been taken into consideration. That is from, if we say that you have first is the straight, then you have meander, and then you have braided. Now, this three are been taken into consideration because this also includes like you have the gradient, then bed load, and of course the velocity. So we have seen that the velocity will also will be different, bed load will be different for different stream or channel pattern. Now, in some cases, uh, it has been clearly indicated that such channels, what we call, if they are getting into the unconfined areas, and that what we call as an alluvial channels. Now these channels are sensitive to tectonic movements. And if we say tectonic movements, then we are talking about the faulting, which can result into uplift or subsidence. Or we can have subsidence. Okay. And when we say uplift or subsidence, then we are directly correlating it with the longitudinal profile. Okay. So basically we will have this longitudinal profile, typical longitudinal profile. Now if there is an sort of an, if we say uplift, then suppose there is a fault here and this portion is getting uplifted. Okay. So what is going to happen in the upstream and downstream? And at the same time, what will happen in the axial part, okay, of the uplift? So it is very simple that this portion will aggrade, aggradation. This will be this will have a sort of an again an aggradation, whereas this part will have erosion because it will try to maintain its path and bring itself in equilibrium. So it has been proved with the like examples or evidence in field as well as experimentally that these alluvial channels are very sensitive to tectonic deformation. And at the same time, we have also seen that they are they will show the changes or they show the influence even in the confined areas in the hilly regions, okay, or the mountainous areas where you have ongoing tectonic deformation. So this part we will talk about when we are talking about different tectonic environments, that how these channels are responding to your tectonic movements. So coming back to the terraces part, which is again, as I told, that it is important for our studies, active tectonics and paleoseismology. So terraces basically represents the older abundant floodplains. Okay, that means that this the area was once occupied by the channels or the deposition. This was the area of deposition where you see the the terraces now, which are we had term we are calling them as a terrace. Okay. Further, they mark the older relative high water level. Okay. That means the stream has flowed at that point in past. Okay. Then the another one is that you will see a sort of an escarpment. Okay. So the last point, if you look at, then it says that the terrace is marked by steps, okay, or thread. So if you look at this in cross section, then it will be something like this. Okay, so you have one step here, multiple steps if possible. Then you have a sort of an, so this will be your river bed. Okay. And these are the terraces which usually we mark as a younger one as a T0, and then older ones are T1. Okay. So let's see some examples of terraces. And keep in mind what we discussed in the previous lecture about the areas, if they are like in longitudinal profiles, if they are uplifted, then what is going to happen in the typical profile, and then if this area is getting uplifted because of faulting, then this area will be eroded over the time. So this portion, the portion where the erosion is taking place, and this is because of tectonics, we can say tectonic uplift. This area will have multiple terraces. Now we will discuss about the terraces, because the terraces are the erosional features, and how we classify the terraces also, that will also we will discuss. Okay. So typical landforms or the landscape, if you see along the channel, then you have the older floodplains as we were talking about, or the abundant floodplains. So this is the older floodplain, that is what we call T1, and this is the younger one, T0. And in this case, and on either side of the channel, we see this landform. Okay. So if you take the cross section here, then you are able to see like this. Okay. So you have what we call this as an paired terraces. Paired is on either side we see the same type of, or classify, if we classify the terraces. So we are having T0 here, we have T0 here. Okay. And along with this is again a natural process which we call natural levees. Okay. And natural levees will usually, if you have a stream bed here, so this will be topographically, it will be slightly higher, and then it becomes gentler as you move away from the channel. Okay. So these are the elevated part, and these are termed as natural levees. So fluvial terraces are also termed as alluvial terraces, formed due to incision or cutting into alluvium or bedrock. Okay. Because it is the process of down cutting, and that will result into the left out floodplains. So it may be seen in the bedrock also. Incision occur as a result of change in base level. So in the previous slide, what we were talking about, that suppose you are having this longitudinal profile. Okay. And in between here, suppose there is a sort of an uplift, or even if you can talk about the subsidence evidence we have discussed in the previous lecture. So this portion is like uplifted area, So the base level has changed at this point. So change in base level as well as the change, there is a change over here. So that is going to affect your channel pattern, depositional, and also it will result into the incision also. Okay. And the change in base level, as we have learned in the beginning, could be due to sea level change caused by tectonic uplift or subsidence, change in discharge conditions that can also result into the change in base level. Okay. If you are having excess deposits, so that can result into the gradation on that part, and that can result into the change in the base level, okay, where the cross sectional area of the channel is reduced. In general, terraces are erosional features. Erosive terraces or erosional terraces are those cut into the bedrock, also termed as strat terraces. Then we have depositional terraces. Depositional terraces are those cut into previously deposited alluvium, and that is what we call valley fill deposits, and they have been cut into that. Okay. So we'll stop here and continue with the more details on terraces in the next lecture. Thank you so much. Namaskar.